Okay, it's important to understand this, and we haven't mentioned it before, so I want you to understand it. Okay? Psi matrix isn't unique, and that's obvious because there are many different ways you can do a solution set, a fundamental set. Okay? You can take a linear combination of two things in the fundamental set and replace one of them with that. That would change your psi matrix. Okay? And there are other less trivial things that you could do. Okay? But a fundamental set, one fundamental set is related to the other. Well, let's go one statement at a time. One fundamental set's related to the other by a simple matrix, because anything in a fundamental set's a linear combination of things in any other fundamental set, right? So we want to kind of get that idea. Psi matrix isn't unique, okay? Since fundamental sets aren't unique, okay? I shouldn't have to say any more than that, okay? And what I've already said, okay? But any fundamental set consists of vectors that are linear combinations of vectors in any other. Fundamental set. Okay? It follows that there's an invertible matrix that connects every fundamental set, any fundamental set, to any other. So if S1 and S2 are both fundamental sets, every element in S2 is a linear combination of elements of S1. Okay? The elements are vector functions of some dimension n. Right? So it's a short jump that I'm not going to, I might detail it. It's just kind of neat. Refresh a little bit in linear algebra. But it follows there's an invertible matrix that connects associated psi matrices and we'll call that invertible matrix C, such that psi 2 equals C times psi 1, which just means if you've got a column of psi 2, which is one of the vectors, in your fundamental set S2, you multiply it by the C matrix, multiply this by the C matrix, okay, and you get a linear combination of vectors from psi 1.
You're just saying, when you're saying it's invertible, you just mean it's linearly independent? Or the...
Well, it's got to be invertible.
Yeah.
Well, yeah, it's linearly independent because the dimensions of these sets match, and these are linearly independent sets. Okay?
So C has to be linearly independent too, because...
Well, C has to be invertible because, okay, if it's true here, it's got to be true that psi 1 is equal to some matrix times psi 2 as well, right? And the matrix you use there has to be the inverse of this matrix. If it wasn't, you'd get a contradiction.
Yeah. Okay.
Okay? And I'm being a little vague because, again, I don't want to get into the nuts and bolts and details. Okay? I mean, you can look into these matrices and see exactly what numbers multiply each element of psi 1 to give you the coefficients of any column in psi 2. And you want to look at it that way. Okay? I don't want to write out the linear algebra of it because I don't want you to have to refresh that right now. Just looking at the overall conceptual thing. And again, you only had a 2-credit linear algebra course. I do recommend a 3-credit when you transfer. Okay? You made the choice to do the 2-credit. It was a good choice. You know, 2-credit almost killed you, 3-credit would have. Okay? You probably made a grade lower. Even though you'd have worked harder, you could have done it. Now we got to the 3 credits, you know, I got to kill people. I don't like that, you know. Injure them, okay, you know, as long as it's recoverable, complete recovery, I'm okay with it. Okay? I don't like anything that maims people or causes long-term problems, much less death. Okay. You're still alive, aren't you?
I didn't take it though, but he's still alive.
You're still alive?
Yeah.
Well, I was going to get to you.
I think so.
Okay. So then you would have probably made a letter grade higher.
Yeah.
Although how can you go higher than A++? That's what you made, wasn't it?
Yeah.
Okay, you did okay. Right? Okay, so anyhow, that's that idea. Okay? And I might invoke that idea on the exam, so you make sure you kind of get it in your head. You don't have to know the details. You don't have to be able to prove it. But you do have to basically understand that any 2 psi matrices for a given equation are connected by an invertible matrix of this form. So that's the bottom line. So
One more class. Then I won't have any classes here. That's kind of fun.
it also, which is probably a little easier to understand, if you were to multiply a psi matrix for a system by any invertible matrix, you would get a set of columns that form another fundamental column set. Okay, so that's kind of worth saying. So multiply any psi matrix by an invertible matrix you get another psi matrix, i.e. another matrix whose columns form a fundamental set. And you should probably try to convince yourself of that. It's kind of an important thing.
How can it be any?
How could it be what?
How can it be any invertible matrix? I guess of the
Any
same
invertible matrix
of the same dimension, I suppose.
of the same, well, it has to be because
Yeah.
you're multiplying it, and that's
Right.
implicit.
Right.
I thought about that when I said it, and I said, no, that's implicit.
Yeah.
Ian's gonna ask, but I'm gonna say you should have seen that.
I mean, yeah.
Yeah,
But
okay, you can't multiply it if it isn't.
is that true because any 2x2 matrix will have to be a fundament or a linear combination of any other 2x2?
Go to 2 by 2. Okay? And work it out. You can do it with 2 by 2 fairly quickly and fairly easily, then you'll understand it. And if you try to work it out, can't, come by and I'll show you some details. Okay? I don't want to lay it on you right now. This is enough. You can verify it for 2 by 2. Okay? Just take a simple equation, go ahead and get your fundamental set. Okay? Just any 2 by 2. And multiply the psi matrix, okay, by an invertible matrix. And see what you get, and then ask yourself, okay, how is this a linear combination of my original solutions?
How would you even test that?
Oh, heck, we'll do it. We got time. You know, okay.
I don't
So,
know.
yeah, we'll do this,
I don't
okay?
know how I'd do it.
I mean, it's worth doing, okay? And I mean, it's, you know, I know you're under a lot of time pressure, so I'll do it for you. Be better for your soul if you did it yourself, but, you know, you asked. So if you come out of this maimed, it's not my fault. No, we'll clarify it. Okay, but let me finish my statement here. And I said equation, it's system. Because I use the word system up here, okay? I'm thinking of the matrix equation, but it's a system. So any two psi matrices for a given system are so connected, meaning that there is an invertible matrix, okay? Another way of saying that is to say that psi 2, psi 1 inverse is invertible. Right? So psi 2, psi 1 inverse is your C matrix. Okay, so again, statement is any two matrices are so connected, and any such product, and any invertible matrix times any psi matrix gives you another psi matrix for that system, and hence another fundamental set.